there's a recommended way to use HttpClient, but if you use HttpClient in that way, you'll actually run into terrible, terrible errors. Let's mash on that. Hi everybody, and welcome to another episode of the Asp.Net Monsters. In today's episode, we're going to take a look at HttpClient and see how using it in the default recommended way might actually cause you quite a few problems. Okay, so to start with, I have a handy-dandy console application here. This is a .NET Core application, but it could be anything. Yeah. This could be full framework. This could be anything that you want here. So this is HttpClient, and this is a very common thing to use. And basically, we're just going to go off here. We're going to start this application. We're going to start 10 times. We're going to go create an HttpClient, and then we're going to go and get this ASP.NetMonsters.com website.
It seems like a great website name. I would
really
go with that one.
Yeah, it is highly recommended that people go there.
They should probably pause the video right now and go to ASP.NetMonsters.com.
They could. We'll wait.
Yeah, great. We'll wait here.
Okay. Glad to have everybody back. Hope you enjoyed your trip over there. So then we're just going to write out the status code here just so I can show that we actually did receive stuff back. And then we'll just write that we're done. So hopefully this will work nicely here. Let's go and just do a .NET run on it here. Let it go. Okay, so it looks like we've done 10 connections out there. All of them are okay. That's excellent. Our website is still up. But now I'm going to pop over here and I'm going to run this netstat tool. So netstat will report all of the open sockets and connections on your machine, amongst a bunch of other things. You can report routing tables and things. But I'm going to use netstat-n, which isn't going to do the name resolution here. So we'll quickly take a look at what's happened here. So just to show you, the application is done. Like, it's completely finished. But if we take a look at netstat here, you can see this collection of connections here, which are in the state called time wait. And this is, in fact, the IP address of the ASP.NET Monsters website. We can just do a quick lookup. And ASP.NET Monsters, we should probably buy that other domain.
Just in case there's only one of us someday.
So that
would be a splinter group of one.
So that's the IP address that we're waiting for here. So these have been left open. So even though the application has finished, it's gone, we still have these sockets open. And in fact, these sockets...
But Simon,
yes.
But Simon, you used a using statement, and HttpClient implements iDisposable.
It does indeed. So the reasoning behind this here is that TCP/IP is an out-of-order delivery tolerant protocol. So that means that the packets that I get back in when I send a request out, and in fact the packets that even the other side receives, may come in out of order. And there's lots of reasons that could happen. So it could be that you send out a bunch of packets and all of a sudden there's a routing change somewhere on the internet and a more efficient route is found. So some of your packets get there before the other ones, or it could be that there's some faulty router somewhere and TCP/IP is it's retry tolerant, so it will attempt to retry those packets. So anyway, you might get these packets out of order, which means that even though we think we're done with this connection, it's possible that there are still packets out there flying about and that they're going to come home to roost at some later point. Now, it's not very useful right now because the application that would be receiving these packets is gone. But Windows doesn't know that, so it's just going to keep these sockets in this time wait state. So by default, Windows will hold connections in a timed wait state for 240 seconds, which doesn't seem like a big deal, except that there's kind of like a limited number of these sockets that you can have open. Windows will ramp up the number that exists, but it kind of ramps up the number a little bit slowly. So if you have all of a sudden a burst of traffic that requires a lot of HTTP connections, using your HTTP client here, it's possible that you will exhaust the pool of connections. And if you do that, sorry, go ahead.
Yeah, I was just going to say, so where this clobbered us on the project where we're working on is that we use a microservice architecture and we're pretty chatty as far as HTTP traffic goes. So we were, doing the thing that we thought was the right thing in attempting to dispose our HTTP client, but behind the scenes, there's these artifacts of all these resources left in this time wait state.
Right, exactly. So even though we felt like we were doing the right thing, we ended up with these connections in this state. And I pulled up the official Microsoft documentation here, which is calling a web API from a .NET client in ASP.NET Web API 2.0.
It actually says guidance at the top too. Yeah, so this is not like it's not like it's just a sample of how to create this class. This is actually under the guidance, under the banner of guidance.
Right. So I don't think we actually followed this. We just felt that we were smart enough to come up with this by ourselves. But if we scroll down here, we can see that like this is the recommended usage here of how to do this. And in fact, this is like inside of an async task. So if you're firing off a bunch of tasks, it's going to open up a new HTTP client for each one. I mean, I felt like I was being slightly facetious in building this up inside the for loop. Like I could have moved this outside the for loop and we wouldn't have this problem, but this is basically the approach that's being recommended here. So like if you're doing something like setting headers on the client in here, and there's a bunch of options that you can set in here, then like you can set the default request headers, and those stay around for the lifetime of the client. So you either have to clear them out after each time or do something else with them if you're going to use that functionality. Like this is the recommended approach, a nice clean client each time, so you don't accidentally pollute it. Okay, so this is one approach, but let's go and clean this up now so that we don't end up in this situation where we run out of ports. Just so you know, if you do run out of ports, there are some nasty exceptions thrown. I have them in the blog post that is linked down there.
In the video notes.
Yeah, so you can take a look at that. I'm hopeful that the error message will climb up the Google ranking a little bit, and that will be the default one that people find, because the advice that we found when we were trying to solve this problem was not to fix HTTP client, but instead to change kind of global registry settings about how Windows handles sockets, which is kind of a scary thing to do, because this might have an unintended side effect on who knows what else running on that machine.
So if you go and take that approach, you might actually solve the problem with your software. You might be able to, because one of the things that they say is taking that 240-second wait time down to like 30 seconds or something like that, which might help solve your problem for a period of time. If your bursting isn't ever as high as what you can be tolerated inside of whatever window you allow for that default time to wait, then that's fine. But you might be clobbering other services that are using this properly. So you go in and change those registry settings, and you're in effect, losing the advantage that you've got over when you do it properly. So.
Okay, so I have pulled down the latest version of this, which should hopefully update this. Oh, what did I not get here? Origin master. This just is not refreshing for me for some reason. Oh, there's the problem. I must have made a change to it. Okay, there we go. Okay, so this is the solution that we came up with, and this is actually, you can find basically this implementation in a very secretive patterns and practices guide that Microsoft have put out. So I have linked that also down below, and you can take a look at that. But basically what we're doing is we're just keeping a single HTTP client around. And this client is going to live for the lifetime of the application. If you're talking to a lot of different hosts, you might consider wiring up like a bunch of HTTP clients, but we're only talking to one here, so we only need a single HTTP client for the entire lifespan of this application. But same basic pattern here. We're going to start our connections. We're going to go and do the get async, write out the status code, and then we'll just show that the connections are done here. So let's go and run that. keeping in mind that last time we ended up with the set of 10 connections here open. So let's do dot run. Okay, there's our 10 connections, and that worked pretty performantly. We'll take a look here. So we don't have anything in that time wait state anymore. I'm going to pull this little filter off here, and we'll go see if we can. Oh my gosh, I have an outrageously large number of connections. Yeah, I don't know if I'll better hunt it down. 23 dot something it was. That's not it. All right. Well, we certainly don't have a lot of connections in that time wait state. So this is already substantially better because we haven't left all of these sockets hanging around. So this means that all of the potential socket exhaustion that you could have has been avoided, and we're not going to crash the entire application as a result of this. So this is kind of our recommended approach to dealing with this problem. Hopefully, if you have run into this, this will save you a little bit of hassle yourself.
Now, some people might argue that using a static there isn't necessarily the best approach.
Yeah, there's certainly other approaches you could do. So this has been instantly instantiated. You could, if you wanted to be super sneaky, you could use like a lazy here to only instantiate this the first time it gets used. You could, if you're using dependency injection in your application, you could wire this up as a singleton and just return the same one each time. I mean, both of those are fairly reasonable approaches. The goal here is not necessarily to instantiate it like as a static variable or anything, but just to only have one in your application. That's the limiting factor right there.
And it is kind of context dependent. I mean, if you've got a series of classes that have different things like, different request headers and whatnot, it might make sense to actually have this instantiated, static or otherwise, inside of a particular class or repository or whatever you're building out, rather than trying to set that up globally through DI.
Right. So one of the things that I ran into when I was backporting this to various places in our application that were broken was that some places were using like request headers. I think the one in particular that was problematic for me was that it was using an accept header. So you can actually build out, like, there are plenty of overloads for get async, so you can actually go on and build out one that takes a proper, like, fully formed request. So all of the options that you would normally assign at the client level are available just on the individual request level.
At the request level as well, right.
Now, can the HTTP client, can that be shared across threads? Is it safe to do that?
Yeah, HTTP client in this case is thread safe, and I think also re-entrant safe.
Okay.
Yeah, so that was a huge performance win, and during our spikes, Simon, do you have that graph handy?
Oh, let me see if I can find that graph.
It was a really pretty graph. I mean, it was.
James's good-looking graph here.
So what happened? You can see there. We've got a couple of days of context here. We started recording the metrics before we released a partial fix, and it's too bad that we don't have a resolution that would allow to see what happened after the complete implementation. But we just went and I'll speak to you in a second here. But after the release, we only implemented the fix in maybe 3 of, I want to say, 6 or 8 places. Simon, does that sound about right?
Yeah.
And we went from this average up around 4,000 sockets in this time wait state at peak down to under or around 100. And after the final implementation, like over the last couple of weeks, we've been sitting down around 30 or 40 sockets in use. So we've gone from 4,000 down to 40. This is, it's hard to overstate the benefit that this has had on the application.
Mm-hmm. And when we were encountering, like, you can see some numbers here are very, very high. So when we were encountering these very high numbers, we were basically bringing down not just the application that had a bunch of open sockets, but we were bringing down like every application on the machine that had network traffic going over it. So this was a very hard one to debug because the failures would be like, hey, we can't connect to the database anymore. Hey, we can't connect to this or that anymore, because basically our pool of sockets was exhausted. We couldn't open any new connections. Yes, that was a fun one.
I know the word fun, and I don't think you're using it right.
Okay.
Thanks, everyone, for joining us again here on the ASP.NET Monsters. Remember to like, comment, share, and send us an email with your comments and questions, just like these folks.
Okay, so back in episode... I believe it is episode 49. James writes in and says, thanks for this, guys. So this was talking about the right-click deployment. And James writes in and asks, thanks for this, guys. Could you do a video where we are using Azure key value pairs for deployment in Azure settings, application settings, key value, i.e. where the deployed version has the production setting and is pulling in keys from Azure, connection settings, strings, secrets, etc. That's actually a really great question. And I think we can probably demonstrate some of the power that exists when you're doing things like using locally user secrets, and when you deploy, how those settings get loaded in via environment variables that are set as part of the application space as the web app runs out in Azure. So that's a great question. Thank you very much, James. Please reach out to us, follow us on Twitter, and we've got your question here. So we've got some stickers for you. Some wonderful stickers. We just need to get your personal details, and we will send them to you wherever you may exist at on this blue marble.
Assuming you're not in a country which is in the axis of evil. Is that still around? Is there still an axis of evil?
I don't know. I'm not
I have
sure.
no idea.
Okay. I'm going to assume it is.
All right.
Awesome.
All right. Well,
All right.
Great, everybody. Hopefully we can get some stickers out to James, and thanks everybody for listening, and we'll see everybody on the next episode of the ASP.NET Monsters.
Cheers.
Bye.
Bye.